All right, hello everybody. Today we are going to talk a little bit about how memory works when you're programming in C, because there are some concepts that we have to deal with when we're doing C programming that you previously probably have not had to use very much if you've been working with higher level languages such as JavaScript or Python. So, at the end of this video, the goal is that you will be able to, at a really high level, describe how a computer's memory model works and understand how pointers are related to this and how we can use pointers in C programming. All right? So, how does memory work? So, in a computer, there are a couple of different types of memory. Specifically today, I want to talk a little bit about the RAM, or the random access memory. So this is your short-term memory. So it's not something that you would use to, not the memory you would use to save a file for weeks or months on your machine, but it's the short-term memory that programs are using while they are running. Okay, and if you're trying to visualize, okay, well, what does RAM look like? You can kind of envision it to be a really big array. Okay, so there's going to be lots of different slots where we can put values. And remember, these values are going to be saved in binary, right? And then all of the different slots where these values are saved all have addresses. So just like arrays have indexes, so we can reference specific values, RAM has an addressing system. It's obviously going to go a lot higher than 7, okay? But it's the same general concept. We have addresses, and those addresses correspond to different values that we might need to reference at a given point in time. All right, so then you might be asking, okay, what the heck does this have to do with C programming? So when we're talking about memory, this is very closely tied in to the concept of something called a pointer, right? So again, other languages like JavaScript, Python, you don't really have to work with pointers, okay? What a pointer is a variable that contains the address in memory to another variable. So it's the address that points to a specific value. So we're used to variables that correspond to a value, right? What's in blue. But when we're talking about pointers, these are variables that correspond to addresses, okay? So, which can be useful in a few specific scenarios. So why might we want to reference something by its address instead of its value? Sometimes it's useful to separate the reference or the address to a variable from the specific value that it has. This can allow us to avoid making lots of extra copies of a specific value, which comes in handy if that value is particularly large. It's nice if we can essentially just draw lots of arrows, lots of pointers to this value instead. That will be more efficient. In C functions that we write, we're only allowed to return one value. So if we know, though, that we have a set of values that we want to be able to reference after a function is returned, we could return a pointer that points to the first value, and then we could use something like pointer arithmetic, which we'll talk about later on in a separate video, to then access all the subsequent values. So it can be a way to kind of point us to a block of values, a set of values, even though we're only allowed to return a single value, okay? And then the other thing, the really useful thing about pointers is we might not know how much memory that we need to use up front. So we might want to be referencing something, but we don't know how big it is. Pointers are a way around that, okay? And specifically where that comes in useful. So there's some data types that have a the size can vary, right? Think about, for example, a string. A string, depending on how many characters it has, is going to require different amounts of memory. Same thing with an array. If an array is longer, it will require more memory. So pointers allow us to deal with these different types of data that have variable sizes. Okay, so this is a big one. This last point here, this is where pointers can be really, really useful, right? So when you're writing a program in C, there are a few specific types of data that will typically require the use of pointers, okay? So data types like strings, structs, or arrays, right? These are all different objects that can have, they could be, some will be smaller than others, right? The size can vary. I could have a string with 2 characters, a string with 200 characters, an array with 5 things, an array with 5,000 things. And again, my struct, depending on how I define it, could have a different number of attributes, right? So typically when you're working with dynamically sized data, it is helpful to utilize pointers. So let's talk a little bit about, okay, so we've talked about what a pointer is. It's a reference to an address rather than a value. We've talked about some different data types that typically require the use of pointers. So I want to look at a couple of examples now of just how to create pointers and some basic operations that we can do with them. So first thing is first, to declare a pointer in C, the only thing that you're going to see that's really different is the use of the star or the asterisk here when you are naming that pointer. So by putting the star in front of the name of my pointer, that indicates to the compiler that this variable should contain the address to wherever the value word is stored in memory. Okay, so I'm creating a variable that points to the address. That's a reference to this value. It does not contain the specific value. Okay, and how this actually works, so let's look at a couple of examples here. So if I create a pointer that is pointing to a string, specifically it's going to point to the first character in that string. So my name pointer here is actually going to point to that S in Samantha. It's not going to point to the whole thing. Okay. Same thing if I create a pointer to an array. So the first line, I just created an array of ints. Second line there, I actually made a pointer to this array. That pointer is going to point to the 1 in my array. Okay, so it's going to point to the first thing in your string, the first thing in your array, the first piece of data in your struct. Okay, so after we have declared a pointer, let's talk a little bit about how we can actually use the address. All right, so we might want to print out that address. If so, when you're using printf and you're using pointers, instead of, you're not printing out a string value, you're printing out a pointer value. So you want to use %sign p as opposed to s, okay? And you'll see that I did not include the star when I printed this out. So if you just want to access the address, you do not need to include the star. We use it to declare that yes, this is a pointer, but we don't need to include that when we're accessing the address. But if I want to take that pointer and actually get the value that is stored at that address, that's when the star comes back into play. Okay, so if I want to actually print out the string value that is at whatever address name of pointer is pointing to, I could do so like this. So if I've got this name, so I could print out the address, so going back to the name example here, I could print out the address where this name is stored by indicating I'm printing out a pointer, referring to the variable name I created for my pointer. And then if I add the star back in, that will actually grab the value that's stored at that address. And this is actually something called dereferencing. So we're dereferencing a pointer, which is just a way of saying we're getting the value that's stored at this address. All right. So to sum it all up, we don't need to use pointers where data type for data types where the size is known up front. There are some situations where maybe we do, okay, but you don't always have to. All right. But pointers are very useful if you're working with data types where the size is not always the same. So dynamically sized data types like strings, structs, arrays that will have different sizes depending on the situation. We can use pointers to help us work with those pieces of data.